It's a real pleasure to be here. I'm going to talk mostly about my experiences and some thoughts that I've learned over these few years that I've been working on open source, and especially focusing on scientific open source. So there's a lot of interaction with open science. And I really want to thank you and the whole pyOpenSci community, as I see so many positive things coming out of this community. And I think it's just really a net positive for all of us to have these spaces where we can chat and talk about things related to making our communities better. So thank you so much. It's also great lineup. So, um, like I said, a lot of the things that I'm going to say do go in the same direction as Eric, and it's just great to have the same synergy and be talking about the same things. But maybe I'm going to approach them from a slightly different perspective. So hopefully this is still going to be useful for people watching. So yeah, I want to get started with a little bit of why I am here and what brings me to this space. So actually, my background is in applied math, more specifically numerical optimization. So I started my studies with a huge focus on being an academic and working in academia and being a professor and being a researcher in applied math. After finishing my studies, I took a position as a professor in the Federal University of Santa Catarina here in Brazil. I'm from Brazil and I am based in Brazil. And I stayed at the university for almost 10 years where I was teaching, I was doing some research, and I was very involved in administration. I was helping put together the curriculum for math undergrad studies there, helping students navigate requirements and successfully complete their programs. Um, and the university where I was is a federal university, meaning here in Brazil, these universities are free and public, which is very different from what you may be used to seeing in the US and other countries. So that may be public servant. And the system here is very different in that once you become a professor, you go through a test and then you are basically tenured. If you're accepted, you cannot be fired except if something really exceptional happens. So I basically, which gives you context for, I think, um, I wasn't super happy at the university. As I got more involved in the day-to-day work, I was starting to realize that teaching was the best part of my day. This was the thing that I liked to do, and just being with students and helping them navigate whatever they needed was the thing that I was there for. And I was not that excited about research as I should be as a professor. And so I figured I was not that good at research, and any papers that I publish would maybe have 3 readers if reviewer 3 actually decided to read them. So the administration part was getting more and more difficult due to a number of challenges, internal and external politics. And there was this general feeling of decadence in our institution. And this was pre-pandemic, so it got even worse after all of that happened. In our department in particular, I was very unhappy about the general view that applied math was not really math. It was kind of seen as inferior. Implementations were seen as mere details, and you wouldn't spend too much time making them better or making them efficient or having unit tests or any kind of best practices for code. And that was really bothering me. I've always liked technology and computers, and I couldn't understand how my colleagues would lack this interest in learning more about what they could do to improve their research. Granted, that's not a universal experience, but in my case, it was a big part of me understanding that this was not where I wanted to be. It works for them, but it didn't work for me. I felt like I was kind of stuck in time. And it doesn't really help that the images that I'm showing in my slide, which is a Google search for math teacher, this is usually the stereotype that you have of a math teacher. It's someone standing in front of a blackboard, writing in chalk. And yes, we did a lot of that, but there's just so much more that we can be doing now in teaching and education and reaching students where they are, which is a world filled with technology and different tools that they can use to improve their lives. Um, As a side note, when I was searching for this image, I actually came across this whole, there's apparently a stereotype of angry math teacher, which is sometimes feeds even more into the stereotype of like, we don't like math and it's hard, it's difficult, it's complicated, teachers are not very nice. And it sounded a little bit like that's what we were playing into by refusing to accept that things are changing and that there were new things that we could be doing in our work. Um, so to give you some little bit more context, this is from when I was teaching, but my actual involvement in open source and free software started way earlier. So I'm going to go back in time a little bit. My trajectory actually started in math, which meant that early on I had to learn LaTeX. So this was a documentation system that's still very heavily used for math because it allows you to write beautiful mathematical equations. This was the year 2000, and I was very lucky to have good teachers, and we soon figured out, me and my colleagues, that it was so much more straightforward, much easier to use LaTeX on Linux than on Windows, which was the system that we were used to. And that was my first introduction to free software, when I actually learned that people were working on things for free and they were sharing this with other people. And it was actually better at doing some things than the commercial offering. So this was incredible, and I was fascinated by it. Not too long after that, I started taking applied math courses, and I eventually landed on MATLAB. So shout out to Eric, who already mentioned MATLAB today. So second mention of MATLAB. At the time, this was the standard for scientific computing at mathematics, engineering, and other sciences. And if you're familiar with it, you know that a MATLAB license can be extremely expensive, even for students, which means that we were relying on a proprietary application that none of us could afford to buy for our education. As you can guess, we pirated it away, and it was like the only way to get anything done. And it didn't make sense to me that we were in a public university with free education and we had to pirate our tools for learning. Oh, Roa, that's amazing. You'll make a third mention in your talk. So MATLAB is the honorary participant at this festival. Later, while I was pursuing my PhD in Belgium, the situation started to change. My PhD advisor shared this understanding that free and open source software was the way. And actually, he had his students follow a 6-week-long course on software licenses, which made me even more aware of all these issues. And it was really a visionary program for the times, and I am really grateful that I had this opportunity. And so immediately we learned about this Python language that was starting to be used for science and math, and started to get really interested about what it could do for us. So before continuing, I want to make a stop here and just discuss a little bit the basics of free and open source. I think there's a lot of people who are still struggling with the definitions and think that free software and open source mean the same thing. And it may not be super important for you day to day, but I think it's useful to have an understanding of how different they are. So we don't need to go into any philosophical aspects of it, and you can do some research if you want to. But I just want to mention a couple of differences. So we tend to bundle together free and open source software into this FOSS acronym, FOSS. But we can actually separate them in a few aspects. So for free software, the source is available, but you require a little bit more than just having the source available. So while every free software is necessarily open source, the converse is not true. So most, but not all, free software operates under what we call copyleft licenses, which is a subversion of the copyright concept. And it means that when you publish this code with a copyleft license, it requires any derivative works to be distributed under the same license. Open source license, on the other hand, are usually less restrictive, and they may allow things like relicensing. So you can even make your software proprietary in the future. This is not very common, but it is allowed. So there are different organizations dedicated to furthering these ideas. So for free software, there's the Free Software Foundation. And for open source, there's the Open Source Initiative, which certifies the use of the open source definition for software licenses. So again, this may not be super important in your day-to-day work, but it is something to be aware of as you are navigating this open source for open science ideas. Okay, so now that I gave you some context, how did I land on open source as my day job? So while I had been involved with the free software movement for a while as an educator and organizer, especially locally, I was not a contributor. I felt like I didn't know how to start. I was not a computer scientist. I didn't know how to use GitHub. And I just felt like I wasn't good or capable enough to contribute. And this, I feel, is a shared feeling among many people, especially as you are not involved at the center of where contributions happen. And what I mean by that is that I'm located in Brazil. So I don't have that much access to PyCon or to SciPy or to these other in-person conferences where you usually make a lot of networking and end up meeting people. And this changed for me exactly at an in-person conference. So this was SciPy 2019. And I ended up there because of, well, several people, but two people here in the audience, I think they're still here, Felipe and Bredo, helped me get there in 2018. And then in 2019, I participated in the sprints at this conference for NumPy and SciPy, met Ralph, and ended up getting a job at Quantsite. So this is not only a testament for how important in-person conferences still are, and how we need to be aware of this with respect to access and how people from the periphery of the world are meeting people and actually starting to contribute, but also how interesting it is that a sprint can help you get a job. When I first joined Quantsite, I was focusing on the NumPy documentation. Since then, I've joined other communities and projects. I've worked on docs, community, and some code. So this is enough about me. I'm going to stop talking about me, and I'm going to focus on open source for science. But I wanted to give you some background and understanding of how you can actually end up doing open source as your day job. So you've probably heard of the scientific Python ecosystem, and I wanted to focus a little bit on why we call it an ecosystem. So this image is from the NumPy paper, and of course it's from the point of view of NumPy, but you could potentially imagine this kind of image going from other foundational libraries. And so at the bottom of the stack, you can see Python, NumPy, and IPython or Jupyter being kind of foundational parts of this ecosystem. And then most other projects will depend on these foundations and build on it. So as you go up in the tree in this image, you see projects that are more and more specialized and more focused on different areas of science. In reality, the connections between projects and communities here are much more complex. It's very hard to be working on one of these projects without connecting with folks from other projects in the space. So the ecosystem is actually very non-linear and interacts with each other. So each node in the ecosystem is different, of course, but the lower you go in the tree, the more people and projects depend on you. So for NumPy alone, you can count hundreds of contributors, thousands of downstream packages, and more than 100,000 repos, which list NumPy as a dependency. We also count millions of downloads a year. So remember when I told you before that I felt like publishing a research paper, maybe I would be read by 3 people? Working on the NumPy docs, I know that at least millions of people are looking at those documentation pages. And so the impact that you can have on open source is huge. And that is directly referencing Eric's talk when he was just talking about the impact that good documentation can have on people. That's exactly how I feel about it too. Now, one thing that may not be very clear for users and consumers of these libraries is that most of the work is done by volunteers. And they dedicate their free time to sustain software and make the lives of the people who use the software better or easier. We use the word community a lot, and it is indeed because of our communities that all of this work is successful. But there are a number of challenges that can come up when dealing with communities, and especially volunteer communities, which is what I'm going to talk about next. I love this picture and I love including it in my slides. So this is a picture from Python Brazil 2019. This is our local PyCon. And we are all, I don't know if you can see that, but we were all doing the Brazilian Sign Language sign for Python. And this is kind of a symbol of how we try to be inclusive in our communities and try to do our best every time to include more and more people into the community. So let's talk about volunteer contributions and how we can deal with that. So community-based open source projects don't necessarily have leaders or a clear direction. They can, but they don't necessarily have it. So in many cases, development happens in the direction where volunteers are willing to work on, which means that some areas of the project may get neglected while others get a lot of attention. So it is often a lot more exciting for people to work on shiny new features than to focus on maintenance, documentation, or any of the so-called boring parts of the project. So this is something to keep in mind, both when contributing to open source, but also as a user, it may be frustrating for you to see that, oh, the documentation is not so good, or there are parts of the project that I wish were more well taken care of. It is sometimes a reflection of where people want to spend their time on. Since there are volunteers, they can choose to dedicate their time where they feel this is more exciting. So in order to organize the work better, many projects will use a roadmap, which is a document usually with a list of features or ideas that will outline the vision for the future of the project. So roadmaps can be used to organize and clearly communicate plans about where the direction of this project is going. Signal contribution opportunities by listing areas where you are looking for more contributions, that saying that you will accept contributions in that direction. And also to identify funding opportunities. So if you have a roadmap and you know where you want to put effort into to improve your project, it is sometimes easier to ask for money to actually fund people working on these features, on these issues, and improving that part of the project. So sometimes people need to actually write that roadmap. And like I said, in projects where you have a volunteer community that comes up organically around a software project, you see leaders emerge or not. It really depends on how the community is organized and how people feel responsible, how much ownership they feel that they have over the project. And as they organize, they may choose to organize in different ways. And so there's a variety of governance and decision-making processes and models that people can use in their projects. So I want to talk a little bit about these different models. I'm not going to be super long on each of those, but just give you an idea of what you can find in different open source projects. So it used to be very common to have a BDFL. So that's a benevolent dictator for life. Someone who is a leader of the project who's going to make the final decisions on road mapping, new features, and the general direction where the project is going. Nowadays, it is much more common to find a steering council model where you have a committee, a group of people who is either elected or nominated and who will make decisions collectively about the future of the project or the future of that community. Some communities work with a voting process where they have actual 24-hour periods where people can voice their objections if there's a decision to be made, and they actually count votes, and they actually have very well written down ideas of how they want to make decisions. Other communities and projects will work on a so-called lazy consensus, which is if nobody objects, this is going to happen. So there are different ways to engage with these communities and kind of understand how they work and how they organize. And as you, either as a contributor or as a funder or as someone who wants to engage with this community, are trying to understand how to best collaborate, it is interesting to know how the community operates internally. You want to be respectful of how people make decisions internally and understand how they would like to proceed. So that's super important. And it is very important to document, which is not something that many projects do. So to highlight what I'm talking about, I think these decision-making processes can sound very complicated or even unnecessary. Um, it really depends on the size of the project and how you are expecting to engage with external stakeholders. But when we don't make these agreements between project maintainers and contributors clear, you can have a lot of tension. It may happen that your consumers, for example, individual users, downstream packages, or corporate or industry users, they have demands that are either unfeasible, they conflict with the project's mission and vision, or they are going to move focus away from other important parts of the project. So if you don't have a decision-making process that accounts for that, that can help you navigate those decisions, it can create a lot of tension in your project. So last slide, I was talking about consumers, the consumers of your project. And I want to highlight this a little bit here. So this is a slide that I poached directly from the CSCCE website. If you don't know this resource, I think it's really interesting and really important. So the CSCCE is an organization that kind of studies, guides, and produces resources on scientific open source community management. And so they have this model for how and communities. And I'm not going to go through all of it, but they do have these different models of consuming, contributing, collaborating, and co-creating. And these are not, so this is not a scale of worse to better. These are just different ways that you can choose to engage with your community. So for many scientific open source projects, they're going to be perpetually in the consume stage, and that is totally fine because that is their vision for how the project should be. Other projects will want to move into a collaborate or co-create stage, and that's how they want to operate, and that's how they want to engage with people. So again, I think I'm not going to go into all of the details here, but I just wanted to highlight that there are people thinking about this, and there are people studying better ways to engage with communities in this sense. So now moving on to a little bit of a different theme, focusing more on the open science idea. This is, again, when we talk about an ecosystem, I first focused on the packages, but now I wanted to highlight a little bit of, I love this tweet by Dario Taraborelli from CZI. And it says that he gave a talk on scientific open source and looked up Matplotlib's dependence based on GitHub data. It's a semi-serious comparison, but as it turns out, Matplotlib has now more dependent repos than the most cited scholarly paper in history has citations. This is 2021, so the numbers may have changed, but I think it gives you an idea for how important and how much impact we have with open source softwares that are actually used in open science, and how people depend on these tools, and how important it is that we are doing things in a collaborative, inclusive, and overall just in a way that helps other people improve their work and further their objectives. So when we talk about open science, again, there's a formal definition of open science, and this is the UNESCO Pillars of Open Science document. It has this nice graph that shows you different pieces. So open scientific knowledge, open science infrastructure, open engagement, and open dialogue with other knowledge systems. I think this is really interesting, and the idea of open science has been around for quite some time now. So I don't think this is new to anybody, but I wanted to focus on my personal understanding of what open science is and just summarizing these ideas. So I believe personally that science should be transparent and that sharing information about scientific research should be the norm. I also believe that data and methods needed to reproduce experiments and reach scientific conclusions should be available, and that anyone should be able to audit those research results. And I believe that scientific information should be free, accessible, and allow for fair and independent investigation. So when I say free, there's a little asterisk there, and it doesn't mean free necessarily in cost, but it means free as in able to be accessed by researchers, by people investigating, and people who can reproduce the results. So to me, that's my interpretation of open science and how we should plan for sharing this information. So I want to talk about a little bit about tensions as well. So we were talking about how to manage communities and how to organize projects internally, but these projects are also going to be used by probably academia, potentially also industry, but I want to focus here on academic groups and research groups. So having these goals of open science and sharing knowledge and sharing data, all of these seem straightforward, but in practice, they're not so easy. Sometimes there's many points of potential friction, and some of these come from different expectations from different groups of stakeholders. So, and for example, in many academic groups, there's a huge focus on predictability and ensuring longevity of code and output, and other groups will need a faster development. They want to guarantee that they have access to the latest methods, the latest algorithms in their field. So when you have limited resources, especially in volunteer-based communities, attending to all of those objectives at the same time can be very challenging. So you can see lots of people complaining about this or the other project online, and I've seen that a lot, which is, oh, this project, they're breaking my code and they're breaking everybody's code. And then on the other hand, this is so old and it's very outdated and they should be doing new things. And there's not enough time or resources to do it all. So there's going to be tension, and there needs to be some way of managing that tension and understanding the expectations and what we can share with people and what people can expect from us. Facilitating the communication between community-driven open source projects and research groups is an area that is growing right now. So there's lots of OSPO groups, there's lots of people in universities focused on facilitating that conversation and even helping researchers publish their code as open source and understanding how to navigate building a community. So that is something to be aware of. Yes, thank you, Leah. With all of that in mind, and if we want to help these open source projects thrive and improve and grow, sustainability, I think, is a key concept to be focusing on. I think a healthy project will be a better experience for contributors, and at the same time, we'll get more things done. So again, thank you, Eric, for mentioning this before, but I will hammer down the documentation once again, because I think this is incredibly important, that ensuring that your documentation is up to date, is friendly, is accessible, and that people know where to find it is really important, not only for your project success, but for the success of everyone that depends on you. So when we talked about all of the impact that Matplotlib has or that NumPy has of all of these projects, of course, these are the big, huge projects, but every project that is used by someone needs documentation and needs clear expectation setting, needs clear understanding of how we're going to engage with people, how are we going to accept contribution, and all of that. So onboarding new contributors, I think it's also really important for sustainability. You want to make sure that people are still coming and that you still have maintainers. Life happens, people leave, and that is also good and positive thing when people leave, when they feel that they can leave because they have something better to do, because they have other things to attend to, because they now have a family or they have a new job. Nobody should feel like they are stuck in a project because there's no one else to pick up their work. So all of these ideas, and I'm promise I'm gonna lead you somewhere with this, but I'm just for the moment, I just want to mention that all of these things are super important. So the last thing that I want to mention before closing is diversity. So it's another issue that is often raised in open source projects. And it is not really unique to the States, but it is something that is noticeable and very uncomfortable in open source. It's a notorious issue that the profile of contributors is majoritarily, and I don't know if this word exists, but is a majority of white, male, and European or American people. Depending so heavily on volunteer work means that we are self-selecting for the group of people who have time to dedicate to volunteer work. And this time is not distributed uniformly through society. If you have two jobs, if you have a long commute, if you're raising children, if you're caring for other family members, if you don't know English, it will naturally be harder to get involved in any kind of volunteer work, especially open source. So many times we are also not prepared to give credit or recognition to different kinds of contribution to a project. So for the longest time, and I think this is changing now, but for the longest time, documentation was not a real contribution. And people would say, oh, but they only do documentation, so they're not going to be a maintainer for this project. And this is only very recently started to change. Understanding that people want to get different things out of their contribution. Some people want to get professional knowledge. Some people want to get networking. They want to meet people. Some other people want to get personal satisfaction from contributing. All of those reasons are valid, including getting the green squares on GitHub. Doing contributions for that is also valid. And if it's going to help them in some way get ahead in life, that's reasonable. But this means, again, that many tasks may get less attention by volunteers because we're valuing code over everything else. And for all of these things that I'm mentioning, how hard it is to get people to work on these neglected areas of the project, some people will say, well, funding is the solution. We need to pay the maintainers. We need to pay people to work on these issues. Yes, but I think there's lots of things that we can talk about with respect to funding. So there are challenges around funding as well. So there's different kinds of funding, and I'm going to quickly go through these kinds, which are the ones that I know about. Maybe you know some others. Maybe you have a different idea for how this works. Lots of projects are funded by grants. So these are either research grants or direct industry grants. There are different kinds. And usually they are very helpful in that they support a project vision. They are a little bit more flexible in the things that you can propose, especially the more recent ones. And CZI and NASA have been really good about offering grant opportunities where you can say what your project needs and that will get funded. But they are usually short term. They're usually 2, maybe 3 years, and people can't make a career out of this. If you're only engaged for 2 or 3 years in this professional setting, it may be hard to sustain a family, for example. You can have direct or in-kind support. So you can have a company that hires you to work on this open source project, or they are giving you support in computers or CI runners or whatever. These can be long-term, but they really depend on company strategy. So these may change from one day to the next. If there's an issue, if there's a layoff, if there's different conditions in the market change, you can lose all of that. There's individual fellowships and awards, but they are hard to plan around. They're not very predictable, and they usually offer support for maintenance. So that is a good thing, but they're not very easy to come by. You can have donations. Donations are very unpredictable as well. They do offer usually support for maintenance. When people donate money, they don't expect necessarily to see a new feature from it, but it tends to be very unreliable. You can fund individual feature development, and there have been a number of projects working on this model lately. So for example, the insiders option of material for MakeDocs and other projects are starting to come up with this idea of, hey, you can fund this feature. It is really interesting, but it does have a focus on new features, and it needs a very well-scoped roadmap. You don't want to find yourself in a situation where you find out later that this problem was harder than anticipated, and there's a company pressuring you to finish that feature. And finally, there are support contracts. You can offer a company support on this specific project or library. Again, depends on company strategy, and it is usually support for new and targeted features and not really maintenance. Other unexpected challenges that can come out of funding is giving people money without a plan on how to spend it or what we expect to get for that money may bring even more problems than solutions. So there's a natural tension that can appear between paid and volunteer contributors. As a new feature that has been paid for and has a deadline to get implemented does require extra work from volunteer reviewers sometimes who didn't necessarily sign up for this extra work. So you always need to be mindful about how these interactions are going to work. Is the paid contributor going to automatically get more weight in the decision making process than a volunteer in your project? Maybe it makes sense, but this needs to be an agreement that you have in your project before you get money. Many times we also expect maintainers to play a number of different roles in projects. So they need to be good at code, communications. They need to have time to respond to all the issues. They also have to write good documentation. They have to make the website look nice. And this can be super overwhelming for a person who maybe initially signed up to do code, and now they have to spend all this time doing things that they maybe don't like or are not familiar with. So if they're getting paid for this maintenance, it can put even more pressure on them to do things that they're just not interested in. So it is really important to have in mind that these are all things that can become invisible because it sounds like it's all part of the job, but maybe it isn't. So you need to have that very clear before you get money. And before I go, because I'm already almost on time, I just wanted to remind everybody. First of all, I don't have all the answers. I brought more questions than answers, and that's usually how I do my talks because I don't have the answers. But I love the conversation. So if you have ideas, please let's chat about it. And I just wanted to remind everybody that open source is just a piece of the open science puzzle. So we also need to think about open data. We also need to think about open access and open standards. And I encourage you all to learn more about these pieces as you're doing open science. If this is your goal, it is important to think about these other things as well.